Bismillahirrahmanirrahim. Welcome to the Structural Engineering Software Application class, lecture number 12. In today's lecture, I will discuss modeling and analysis of truss, earthquake load, wind load, foundation or head and underground tank in ETABs. And some other utility command and tools will also be discussed like section designer, auto select list and cylindrical grade system. Lecture outlines are objective of today's lecture. Example analysis of truss in ETABs. Example earthquake and wind analysis of structure. Example on analysis of foundation in ETABs. Example on analysis of overhead and underground water tank in ETABs. Then cylindrical grid system. Then application of utility tools in ETABs like section designer, auto select list. And at the end, class task is given for the student practice. Now lecture objective. By the end of this lecture, the student will be able to model and analyze truss, foundation, overhead and underground water tank, earthquake and wind load analysis of structure in ETABs. And the student will be able to use the utility tools and command in ETABs like section designer, auto select list and cylindrical grid system. Now example on analysis of truss in ETABs. In the example 2D truss is given which is subjected to 4 different loads and all the section or all the member in the truss element is W14 cross 30. Now let's discuss how to analyze this example in ETABs. Again 3 phases are involved. In phase 1 the following steps are includes. First of all, we'll create a new model, right? Then define a grid system, then edit grid system if required, then define materials, define section, that is a steel section W14 cross 30, then define load pattern, load cases, load combination, right? Then draw elements, then assign joints, assign loads and release moments, right? So for the all different steps except release moments, you can refer to lecture number 11. Once phase 1 is completed, then phase 2 is analysis and phase 3 is post processing where different result will be displayed. While analyzing a truss element or structure, keep in mind the different assumption related to truss, that is the joint of different element in truss will be fractionless joint, right, pin joint, and the member will be considered a weightless, right, and all the load will be applied at joint. Now I will discuss phase 1 in detail. First step is to create a new model, then edit grid system if required, then define materials where put density equal to 0 as per the assumption of truss element, then define section, that is W12 cross 30. For that, go to define section property, click on the frame section and then import steel W14 cross 30 section, right? So here is the W14 cross 30 section is imported, right, having different section dimension. You can convert this section dimension to user define in order to change the value if required. Then define load pattern where put self weight multiplier equal to 0, right, as per the assumption of truss element. Then define load cases, load combination and draw elements, then assign joints, then assign load at different location. So this is the final model where the load is applied and the joint are assigned. Once the model is completed in all respect, so then we can release moment. For that, select all the members of the truss, then go to assign, then frame, then click on releases, right? So this window will appear. In this window, release moment 22 and moment 33 at start and end, then click on OK. So the moment will be released at a different location. Once the moment are released at different location, then we can run analysis, right, and then we can display different results. So these are the different results. First one is the displacement, right? A second diagram give you the reactions at joints, and third diagram give you the axial forces diagram, right? And the final is the moment 3-3 diagram, and as per the truss definition, so there will be no bending moment in the truss element, so it's shown zero bending moment. And now let's see how to solve this truss example in ETABs. And now first step is to create a new model. For that, go to file, then new model, right? Then change the unit. The unit will be metric SI, and the steel section database will be AISC 14. Click on OK. Then define grid lines. 4 grid line required in X direction, so no grid line required in the Y direction, and the spacing between X grid line is 2 meter, and for Y keep it equal to 1, and similarly we required 1 story, and the heights will be 2 meter. Then click on OK. So the grid lines are developed. Now we will see an elevation. Now next, to define the materials property, for that go to define materials. Let's suppose I will use 400 psi material, then modify and show this material, and I will keep the weight density equal to 0. Click on OK. Step is to define frame section, so I will define W14x30 section. For that, go to define, then section property, frame section, right? So I can import W14x30 section, but it is already available in the database, right? If you still want to import it, so click on import file, import section, then steel section. So we imported already from the given file, right? You can also import it if you want. If you want to import some other kind of section, so for that, change the section type, so it will be accordingly displayed in the frame section list. So from here you can check our W14x30 section, so you can also check it the different dimensions. So these are the different dimension of W14x30 section. Okay, similarly you can also convert any particular section to section designer section, or you can also copy it to section designer section option. Now next step is to define load pattern. For that, go to define load pattern and keep self weight multiply equal to 0. Click on OK. So now I'm going to skip other step like load combination and load cases, and I'm directly going to draw the truss elements. So for that, I will choose draw beam and column option, and then I will choose W14x30. I will draw different section as per the diagram. Okay, the ETABs develop different joints. It is the hinge joint by default at base location, so we can change it to pin. So select the joints and then go to assign, then joints, restraint, and convert it to pin. So the different joints are converted to pin. Now we will draw the rest of section. I will draw the rest of section. Right, then I will assign joints. Here it is a roller support, so assign roller support over here, and it is a hinge support, so assign. Now I will assign load at different location. So here the load is 20 kilonewton, so select this joint and then go to assign joint load and forces, and here we will apply minus 20 kilonewton load at opposite to z direction. Click on OK. Similarly, here is the load is 25 kilonewton. So select this joint and then go to assign, then joint load, forces, and apply here 25 kilonewton load, and then at this location there is a 10 kilonewton load. Then go to assign, joint load, forces, 10, and here is 15 kilonewton load is applied. Joint load, forces, and 15 kilonewton. Right. Okay, once the model is complete in all respect, then we are in position to release moments. So for that, select all the joints including the members, then go to assign, frame, then click on releases, and then release moment 22 and 33 at start and end location. Click on OK. So the moment are released, and now we can analyze this truss element. So then click on run analysis and save the file. Okay, analysis is completed. When we can display now different results. So it is a displacement diagram. We can display the joint reaction, right? Similarly, we can display the axial forces, right? And we can also display other parameter we required, like we can display moment 33, but it will give you zero result because it is a truss element having no bending moment. So this is all about truss analysis and ETABs. Now example on earthquake and wind analysis. So I will consider any 2D or 3D frame structure, and I will use the following data for earthquake analysis for both static and dynamic, including time history and response spectrum. And for wind load analysis, I will use the following data. Okay, the following procedure will be adopted for earthquake and wind load analysis in ETABs. So all the steps are same as I have discussed in lecture number 11, but there is a few step that is different in case of earthquake and wind load analysis. So I will discuss only that. Okay, in one step is define load pattern for earthquake if I am using a static load procedure for earthquake, and I will define load pattern in case of wind, right? Okay, if I am using time history and response spectrum for earthquake analysis, so I will define function accordingly. And similarly, I will define load cases for time history, response spectrum, and wind and other loads. Okay, in case of static force procedure for earthquake analysis, I will define load pattern for earthquake, right? So from here I will define load pattern for earthquake along x and y direction, and I will choose UBC 97 code, and in the type I will choose seismic load, right? So once the earthquake in both direction are added, okay, when you click on the modify lateral load, so this window will appear. From here we can change the direction eccentricity. In case of x direction, we will only consider x direction. For in y direction, we will check only y direction. If there is any kind of eccentricity involved, so we can check the relevant boxes. Then I will enter the seismic coefficient like soil profile, seismic zone factor, and seismic source type, right? Then importance factor, right? For time period, so I will enter the coefficient CT value, and in case of story range, so it depends on the number of stories. So you will specify the top story and the bottom story here, then enter the R factor, that is our strength factor. Okay, by this way we can define a static force for earthquake, right? Once this step and all rest of the steps is completed, then we can go to the phase 2 and phase 3. Okay, for in case of time history analysis, we can define a time history function. For that, go to define, then time history, right? So this window will appear. From here we can choose file. So from file we can browse the relevant time history. Okay, for the rest of information given in this data form, you can refer to lecture number 9. Okay, once the time history function is defined, we can then define the load cases for the time history along x and y direction, right? So for that, go to define, then load case, then add a new load case along x and y direction, right? And from here, choose the load case type time history and add acceleration along u1 x direction, and for along y, choose u2. Okay, once the time history analysis and other steps are completed, then we can analyze the structure and then we can display different results. Okay, in case of response spectrum analysis, again define function for the response spectrum. For that, go to define, then function, then click on the response spectrum. So this window will appear. From here, choose the code, that is UBC 97, then click on add new function. Okay, so this window will appear. From here, you can enter the seismic coefficient CA and CV value that depend on the seismic zone and soil type. So when you enter the value, so it will give you the response spectrum graph, and you can display your graph in different way, along linear x and linear y, linear x and log y, log x and linear y, and log x and log y. Okay, once the function for the response spectrum is completed, then we can define the load cases for response spectrum along x and y direction. For that, go to define load cases, then add new load case along x and y direction. In load case type, choose response spectrum and then enter u1 for x direction and then u2 for y direction. Okay, once all the steps are completed, then we can analyze the given structure or we can display different result in phase. Okay, in case of wind load, again define load pattern for the by using UBC 97. So here we will add the wind load pattern, right? And then click on the modify lateral loads. So this window will appear. In this window, we can enter the different coefficient, including the wind speed, the exposure type, the importance factor, then exposure height, top story and bottom story, and if there is parapet wall is also exposed to the wind, so we can also check it, and we will enter the height of parapet wall. And similarly, we will enter the exposure and the pressure coefficient. Okay, when phase 1 is completed, then we can analyze the structure and we will display different results. Now let's see how to analyze any structure for earthquake and wind load. Create a new model. I will consider any 2D structure. Let's suppose there is 4 grid line x direction and 1 grid line y direction, and the spacing between grid lines are 3, and I consider let there is 3 story and each story height is 3 meter. Right, now I will consider any frame element and I will draw the structure, any by default frame structure, frame section, right? Then I will define. Now I will skip all other steps and define load pattern, load cases, and define function. So first of all, I will define load pattern for static earthquake case. Go to seismic and then I will define seismic load pattern along x direction, and I will delete the other patterns, and then I will add along y direction and I will use UBC 97. Modify the lateral loads for both x and y direction. For x direction, I will just choose the direction x direction, then I will change the soil type to SD and it is zone 4, right? And important factor is 1.25, its value is 0.03, and R factor is 5.5. Similarly, I will repeat the same for earthquake along y direction, and I will choose only y direction, and then change the soil type to SD, and change the ST value to 0.03. Importance factor is 1.25 and R factor is 5.5. Right. Similarly, I will define load pattern for the wind. So I will choose the wind. I will change the load name to wind. I will use the UBC 97 code, modify it. Then I will modify lateral load for wind. Here 100 miles per hour, and the exposure is, let's suppose B, and the importance factor is 1.25, and I will keep rest of the value same. Click on OK. Okay, the wind and earthquake load pattern is defined. Click on OK. Now I will define a function for the time history and response spectrum. For that, go to define function time history. So I will choose from file, add new function, and I will browse the El Centro. So choose El Centro. Okay, El Centro earthquake time history is imported. So we can view the file. So there is 3 point per line. So we will change it to 3, and there is no header line to skip, and we will display the value in this format. Right. So we can change the name of the time history function to th. Click on OK. OK. Then I will define load cases for the time history along x and y direction. So I will add new load case. So thx for the time history, and I will add acceleration at u1 direction, and it is th1, and the scale factor is 9.81. And again I will add copy of time history along x direction. I will change it to y, and I will change u1 to u2 for time history along y direction. Now I will again function for the response spectrum. Go to define function and response spectrum, and choose UBC 97, add new function, then I will enter CA and CV value. Okay, so it will give you the response spectrum for the given CA and CV value. So I will change the name to RS. Click on OK. Click on OK. Now I will define load cases for the response spectrum along x and y direction. Add new load case. So it is response spectrum x direction. I will choose response spectrum from here. I will enter acceleration in u1 direction, response spectrum from the function, and it is 9.8. Click on OK. Now I will add copy of this response spectrum load case, and then I will change the name to RSY and change it load direction to u2. Click on OK. Click on OK. Okay, the model is ready for the analysis. Now I will just click on the analysis, and I will save this file. Okay, once the analysis is completed, now we can display different results like a deformed shape along x direction or y direction. Click on OK. So it will give you the displacement or deformed shape for earthquake along y direction. You can display results like moment 33, Okay, and we can also display deform shape for time history and response spectrum. Right, this is all about analysis of earthquake and wind in ETABs. Now analysis of foundation in ETABs. So I will consider example given in this slide, and I will model a single story frame structure, and the foundation area is 1 feet more than the superstructure, and the KS value for the spring is 4200 kilonewton per meter square. Plan of structure is 10 by 10 feet and the elevation is 10 feet, and the foundation will be 1 feet more than the plan. Okay, the following step will be adopted for analysis of foundation in ETABs. For all steps, kindly refer to the lecture 11. So I will discuss only how to assign spring in ETABs. Okay, for that select area, then go to assign, then area, then choose area spring. So this window will appear. From here we can assign spring. Okay, in case of foundation, the spring will be compression. So I will enter the spring constant value in the local axis 3 compression only, that is 4200 kilonewton per meter square, and I will choose compression only in non-linear option for local 3 direction. Then click on OK. So the spring will be assigned accordingly. Now let's see how to solve this example in ETABs. First of all, I will create a new model. Two grid line required in x direction for plan and 2 required in the y direction, and the spacing is 10 meter. Okay, so here there is one story only and the story height is 10 meter. Then I will customize the grid dimension for plane in order to incorporate value for foundation grid line. I will add two grid line. One will be having 11 meter spacing and the other will be 8 minus 1. Similarly, along y direction, I will draw a slab at story 1 level location, any by default slab, and then I will move to the bottom and I will draw foundation here. Right, then I will draw frame elements. Right, then again I will go to the base level, mesh the foundation, go to edit shell, divide shell, and I will divide it to 10 by 10. Okay, once the foundation slab is mesh, then we will assign spring. For that, select the foundation, then go to assign, then shell, then choose area spring, add new property, and here I will enter 4200 value of spring, and it is compression only. Click on OK. So spring are assigned. We can analyze the given structure. Okay, once analysis is completed, then we can display different results. We want to display a maximum bending moment, so it will give you the maximum bending moment value in foundation, right? So this is all about the foundation analysis and modeling in ETABs. Okay, now I will discuss how to analyze our head water tank given in this slide. Okay, the following step will be adopted for analysis of our head water tank in ETABs, and I will discuss each step one by one in upcoming slide. First of all, I will create a new model and then create a grid system. So two grid line required in x direction and two grid line required in the y direction, and the spacing will be 4 meter each, right? Then 3-story required along z direction, and it is the story data, right? And the height of each story is given over here and along with elevation. Okay, once the grid system is developed, now next step is to define materials, then define different section including beam, column, slab and wall. For slab and wall, use shell thin type. Then define load pattern. So we'll define a load pattern for the water pressure load, others. So from here we will choose other for water pressure in load pattern type, and the self weight multiply for that will be equal to 0. Then define load cases and load combination if any. Then draw different elements: beam, column, slab and wall. Okay, for wall we will use the draw wall option, right? And we will draw a wall in the plane, so it will give you a result in elevation. Okay, once your model is completed or it is drawn, so it will be shown like this. Then mesh area elements. Now assign loads. In case of water tank, the water pressure or load is applied on the bottom and side of water tank, right? So first of all, I will apply a water pressure on the bottom slab of the water tank. So for that I will determine the pressure. So it can be determined by using the formula P equal to gamma H, where gamma is 9.8 and H is equal to 2 meter. So the total pressure that will act on the bottom slab of the water tank will be 19.6, right? So for that, go to select bottom slab, then go to assign, then chain load, right? So this window will appear. From here, load pattern name, change the load pattern to water pressure, then enter 19.6 uniform load in the gravity direction, then click on OK. Now I will apply water load or pressure on the side wall of the water tank. So this diagram shows the water pressure distribution on the side of the wall, right? So this load is applied in the form of non-uniform load, right? So for the non-uniform load application, there is a function available in ETABs, and its function is equal to AX plus BY plus CZ plus D, where A, B, C and D are different constant. In case of water pressure in the side wall of the water tank, the AB will be equal to 0 because the load is only distributed along Z direction, right? So the equation become P equal to CZ plus D, right? Now I will use the boundary condition to determine the C and D value. So the first boundary condition is when Z is equal to 0, so P will be equal to 19.6. This P value I have determined in the previous slide, right? When I put Z equal to 0 and P equal to 19.6 in the equation 1, so it will give you D equal to 19.6. Similarly, the second boundary condition is when Z equal to 2, so P at this location will be equal to 0. So it will give you C equal to minus 9.8 kilonewton per meter square. Okay, once A, B, C and D values are determined, then select all wall members, then go to assign, then click on the shell loads, then click on the non-uniform load. So this window will appear. From here, change the load pattern to the water pressure, then change the direction to local 3, and then enter A, B, C, D values in the relevant boxes, then click on OK. So the water pressure on the side of wall will be applied. Okay, when the load is applied, then we will assign joints. Okay, this is the final model, and the model is ready for analysis. Once the analysis is completed, we can display different results like displacement, the moment 33, right? Similarly, we can also display maximum bending moment in the bottom slab and side of wall, and we can also perform designing. For that, go to design and then choose concrete frame design. So it will give you a reinforcement in different location shown in this figure. Okay, in case of underground water tank, all the steps will be remain same except the soil pressure that will also act in the side wall of the water tank, but the direction of the soil pressure will be opposite to the water pressure. And we will apply the soil pressure as a non-uniform load, as I have discussed for water pressure. We will follow the same procedure. So this function will be used. We will determine a, b, c and d value. In this case again a, b value are 0, and we will determine c and d value by using the boundary condition. In case of first boundary condition, z equal to 0 and p equal to 30 kilonewton per meter square, where p is determined by using p equal to gamma h formula, right? So when this boundary condition is entered into equation number 1, so it will give you d value, that is 30 kilonewton per meter square. Similarly, boundary 2 condition is when z is equal to 2, so the p equal to 30 kilonewton per meter square. So when you will enter these two value in the equation 1, so it will give you c value, that is 0. As I told you, the direction of this soil pressure is opposite to the water pressure. So for that we will define the load case having scale factor equal to -1, and we will also assign spring beneath the base slab, because in the case of underground water tank it is placed on soil. Okay, in future if you come across any kind of soil or other kind of pressure that is applied on side wall of the water tank or any other side wall, so how you can apply this kind of load in ETABs. So I consider this is an example, right? Again I will use the same equation, right? And in this case again a, b value will equal to 0. So for c and d value I will use the boundary condition. Okay, the first boundary condition is when z equal to 0, so the p will be equal to 19.6 plus 30 value. It will be the combination of these two pressure, right? So then we will enter both value in the equation 1, and you will obtain a d value. Similarly, by using the boundary condition 2, where z equal to 2, so the p value will be equal to 30 kilonewton per meter square. By this way you will obtain c equal to -9.8. So this now let's see how to analyze or head water tank in ETABs. I will solve this example. Okay, first of all create a new model. Okay, 2 grid line required in x direction and 2 grid line required in the y direction, and the spacing between these 2 grid lines are 4 meter. Similarly, 3 story are required, and I will keep the story height, the bottom is 4 meter, and I will keep the top typical story height 3 meter, and I will customize the rest of story data. First story height is 2 meter, second is 4 meter, and first is also 4 meter. So click on OK, click on OK. So the grade lines are developed, right? Now next step is to define cross section, and I will use by default materials property. For that, go to frame section, then add new section. So I will add a rectangular concrete section, right? And it is a beam. So the beam dimension is 300 by 350. So the height is 350 mm and width is 300. I will change the reinforcement type to beam design, then click on OK. Again I will define a column section, right, and it is 300 by 300 mm. Click on OK. And now I will define a slab section. Define frame section, then slab section. I will add new section. Let's suppose it's 20 mm. Now I will define a wall section, and then add new section, wall, and it thickness is 180 mm. Click on OK. Click on OK. Now I will define a load pattern. Go to define load pattern. So I will add other as a load pattern, and that is water pressure. Right, click on OK. Now I will draw a different section, draw column section. For that I will choose column, and then I will change the elevation, and I will draw all the columns. Right, then I will move to the other grid lines and draw column accordingly. Similarly, I will draw beams at different location. Okay, once the beam and column are drawn, then I will draw slab, bottom slab of the water tank, and bottom slab is actually its story 2. So I will choose slab option, and then I will choose slab. Just draw a wall. For that, choose wall section, that is wall, right, and then go to plan of top story, story 3. Okay, you have to draw wall in plan. Okay, wall is drawn. We can check it in 3D. Right, I'll mesh the slab and the side wall. So for that, go to plan, second story, then choose the slab, then go to edit shell, and I will divide area to 10 by 10. Similarly, will mesh the side wall. For that, select all the walls, then go to edit shell, and divide shell. Okay, so I will divide the shell element into 10 by 1 because the load well is actually distributed in one direction. So I will just divide the walls into strips. Right, now I will assign different loads. For that, go to plan, story 2. I will apply load on the bottom slab. So select this slab, then go to assign, then shell load, then uniform load. So here I will enter 19.6 uniform load in the gravity direction, and I will change the load pattern to water pressure. Click on OK. Right, now I will apply non-uniform load on side wall of the water tank. So for that, I will select all the side wall, right, then go to assign, then shell load, then non-uniform load, and I will change the load pattern to water pressure. So A equal to 0, B equal to 0, and C value is minus 9.8, and D value is 19.6. So click on OK. Water pressure is applied to the side wall of the water tank. Now our model is completed. Now we can run analysis. Analysis completed, we can display different results like deform shape for the water pressure. So this is the water pressure applied on the side of wall and the slab, the bottom slab, and we can also display a bending moment 3 right, and also we can display a result for shell element like M maximum, right. Similarly, we can perform designing. So go to design, then concrete, then start check in design. So when the design is completed, it will give you their reinforcement at different location. This is all about how to analyze and model our headwater tank in ETABs. Okay, now I will discuss how to create cylindrical grid system. Cylindrical grid system is actually the combination of radial and circumferential grid lines, and these grid lines are parallel to the XY plane of the grid system. In order to create a cylindrical grid system, right click on your grid lines, then click on the add and modify grid line, then click on the new grid lines. So this window will appear. From here you will change the grid system type from Cartesian to the cylindrical. Grid system, you will enter two type of grid lines. One is represented by R direction and other is represented by T direction. R direction is actually the number of circles, right? It is shown in the figure, and T direction shows the transverse grid lines, and it is represented by these radial lines, right? And the spacing of grid line in R direction is represented by S1 in the figure, and spacing of grid line in the T direction is represented by S2, and S1 is represented in the unit of length, feet or meter, and the spacing of grid in the T direction is represented by the degrees. Okay, in this figure, for grid line in the R direction, right, this is 1, 2, 3 and 4, right? The number of grid line in T direction is determined by this formula, where is equal to total degrees. In this example there is 360 degrees, and the spacing between each grid lines is 30 degree. So this will give you the total number of grid line, and you will add +1 with this to complete your circle. Okay, in case of multiple grid system, you will specify your origin orientation of your particular grid system. From here you will enter the global X, global Y and rotation about global Z direction. Okay, in this example, number of grid line in T direction are 61, and it is determined by this way, 360 divided by 6 plus 1. Okay, in order to define this cylindrical grid system, again go to edit, then add modify grid system, then add new grid system. Here you will change the different values. Number of grid line R direction is 3, number of grid line in T direction is 61, and the spacing of grid in R direction is 10, and spacing of grid in T direction is 6 degree. So it will give you the grid system, that is cylindrical grid system, for the example. Now example, in this example there is two different type of grid system involved. One is cylindrical and other is rectangular. So let's see how to develop two grid system in single model. First of all, I will add Cartesian grid system. So for that, number of grid line in X direction are 4, and the spacing is given in this table. Similarly, number of grid line required in the Y direction are 3, and the spacing are given in this table. Now I will add cylindrical grid system. In case of cylindrical grid system, number of grid line in R direction, let's suppose 2, and number of grid line in T direction we can determine by this formula, 180 divided by 15, because the spacing of grid in T direction is 15 degree and +1, so total 13 grid line required in T direction, right? And the spacing of grid line in R direction is 8 and is per the example. Then click on OK. Now the cylindrical grid system is developed, but it is not at the location where we want. So for that we will enter the grid system origin or orientation in order to keep it at location where we want. Okay, the origin of this will be global X value will equal to 0 and global Y will be equal to 8. So it will shift from this location to this location, right? And again we want to rotate their grid system in order to place it exactly at location. So for that we will enter rotation angle, and in this case the angle of rotation will be equal to 90 degree. When I enter the 90 degree angle, so it will be rotated accordingly. So this is the complete grid system developed, combination of rectangular and cylindrical grid system required. Now let's see how to develop cylindrical and rectangular coordinate system in ETABs. First of all, go to File, New Model, then create rectangular grid lines. So we required 4 grid line in x direction and 3 grid line required in the y direction, and I will keep the spacing 8 and 2, and then I will customize the grid spacing. Okay, in case of x direction, first location will be 0, the second will be at 4, 10, and 14.3. Okay, along y direction the spacing is 8 meter. It is okay. Click on OK. Right. So the rectangular grid system is defined. Next is to define a cylindrical grid system. So for that I will add a new grid system. I will change value to the cylindrical. Okay, number of grid line required in r direction, we required 2 grid lines, and number of grid line in t direction is 13, and the spacing between r direction line is 8 and the degree spacing is 15. Right. Okay, the origin is 0 at 8 location and orientation will be at 90 degree. Click on OK. You can see, so the grid system in the example is developed. Okay, now application of section designer. Section designer is integrated utility in ETABs that enables the modeling and analysis of custom cross section. Right. In order to access the section designer, go to define, then section property, frame section, then click on add new property. Right. So this window will appear. From here you will go to the special option, and from this option we will choose section designer. So this window will appear. From here we will change the property name, and we can change the base material, and we can change the design type, and then we will just click on the section designer. So this tool will appear. For further detail about the section designer, kindly refer to lecture number 10. I have discussed that in SAFE 2000. In both software, the section designer application is same. In case of ETABs, you can change the background dimensions and the color of different section or elements by go to draw menu, then from setting you can change the different drawing option. Now auto select list. Auto select list is used for the most economical and optimal section during steel structure design. So in case of ETABs, you can import steel section first, then go to define, then section property, frame section, and then you can add auto select list as a section, and then you can add different section to this particular auto select list. Right. And then you will draw your element by using this section, and later on you can do your designing, and it will give you the most economical and optimal section during steel structure design. So for the detail about auto select list, kindly refer to lecture number 10. Now task for the practice. Task 1 is analyze the truss structure given below. Task 2 is to analyze given structure for earthquake and wind load analysis. Right. Also model foundation. Note use data given in slide number 10. Task 3 is to model and analyze circular or head and underground water tank given below. Assume any missing data. For underground water tank, consider circular tank portion only. Task 4, design the following section using the section designer utility and ETABs. Thank you so much. This is all about lecture number 12.